Hi, welcome to today's lecture. We're going to pick up where we left off in Chapter 19 and create a multi-threaded server. So this example will take understanding of the TCPListener class, the TCPClient class, and threading. So threading is covered in another lecture. This lecture, like I just said, comes from Chapter 19 in the book C# for Artists, 2nd edition. Okay, and we're going to jump to page 564. And building a multi-threaded server. Okay, the previous exercise or lecture was building an echo server using the TCPListener class and the TCPClient classes to work together to create a server application and a client application. Okay, the difference between this application and the previous example is that this application will also be echo server, but we can hook up multiple clients to the server at the same time because it's going to be multi-threaded. So general steps to turn echo server from the previous example into a multi-threaded echo server is we're going to create a separate client processing method, okay, that handles the network stream communication and other applicable processing between the server and the client applications. This is going to be necessary because as soon as the server detects an incoming connection, we're going to want to spawn the resultant TCP client connection into its own thread so that that can process independently and allow the server to go back and listen for other incoming connections. Imagine if Amazon did not have multi-threaded servers, right? You would have a wait line of people trying to get into the app because they couldn't connect. Okay, so every web server is multi-threaded underneath the covers. Okay, so this is a way for you to write multi-threaded apps as well. Second step is for each incoming client connection to spawn a separate thread passing the name of the client processing method. And threading is covered, I think, in Chapter 15 or 16. I have to go back and check. But so let's pull up the code. So the code for this example comes out of Chapter 19, multi-threaded echo client server. And we'll take a look at the server code first. So crank up Notepad++ and drag over the multi-threaded echo server class. Okay. So starting from the top, we've got the system IO or system namespace, system IO, system.net, system.net sockets, and system.threading. And sockets, we're not really using sockets, but I'd put the namespace in there anyway. All right, now we got our class, multi-threaded echo server, and then we have a method called process client request. I'm going to collapse that for now, and we'll come back and talk about that later. But I want to focus on the main method. So the main method begins here on line 42. And the first thing we do is we create a TCP listener, okay, and set it to null. And then we have a try catch block. Notice the guts of this main method are a whole lot, there's a whole lot less code than the echo server. That's because the client processing connection or logic is contained in a separate method, which is this process client requests method, which I've made a static. You could make it an instance method if you wanted to. I got it static here in this case. But on line 18, I'll go into that method here in more detail in a second. But back to the main, we have a try catch block, and then we have a while statement in the middle of the try block. And it just repeats indefinitely, really. We just want our server to power up, okay? Start listening for incoming connections on 127.0.0.1, port 8080. Okay, we start the listener, and then we print out a message to the console that says multi-threaded echo server started. And then we enter our while loop. Now, the first thing that the body of the while loop does is print out a message that says waiting for incoming client connections. Then we create a TCPListener, TCPClient, called client, okay, reference. And the listener.acceptTCPClient method is called, and there it blocks. This while loop blocks until it receives an incoming connection. As soon as it receives an incoming connection, it unblocks, returns a TCPClient object, which the client reference then points to. And then I write another message to the console saying accepted new client connection. On line 52, this is the big difference between the, multi-threaded and non-multi-threaded, is I'm using a thread object called T. It's a type thread equals new thread, and I give it the name of the method that we're going to use to process the client requests. So I say new thread process client request, so it's going to call that method right there. And if you'll notice, I'm using the version of thread for the parameterized thread start, okay, which takes an object as an argument. Now we know as programmers here, we know that the type of object being fed to this method is going to be TCP client. Okay, so we'll keep that in our back pocket. We create the thread, tell it which method to call, and then we pass and then we call t.start, so thread.start, okay, on the T reference, and pass in the TCP client object. And as soon as we call thread.start, a new thread is spawned. The while loop then circles back around, starts another iteration. Okay, we create another client, and then the listener.acceptTCPClient blocks until another incoming connection is detected. And then the whole process repeats itself. We print out a message, we create another thread, and call thread.start or t.start in this case, and pass in the client TCP client object. Okay, when the application exits, if there's an exception, we write the exception to the console, and finally we'll stop the listener. Okay, that's all the main method's doing. Now let's jump up here to line 18 and expand the process client requests method. Okay, we know we're passing in an instance of TCP client. So first thing I'm doing is casting the argument, which is an object. Okay, it's just a simple object. I'm going to cast it to TCP client, and I'm going to assign it to my client reference. Then I'm going to use the client.getStream method to create me a reader and a writer. So we've seen that in the previous example, stream reader, stream writer. The stream reader and stream writer classes, again, are found in your System.io namespace. And then we have create an empty string, S, and then this code looks pretty much like the rest of the code we had from the previous example. While S is not equal to exit or null, get whatever the client sends you and write it to the local console, and then write it back to the client using the writer, and then flush the writer. Okay, if it's null or exit, then we finish this while loop, or we exit the while loop. We close the reader, close the writer, close the client, and if there's an exception, we write out the problem with client communication, exiting thread, and then the final thing that we do is we make sure that the client connection is closed. And that's pretty much it. So overview is we have a server app that's using a thread class to enable multi-threading. Incoming connections detected. Down here in the main method, we create a new client. When the accept TCP client method returns, we then create a new thread, and by passing in the name of the method that the thread is going to call when it starts, okay, and we pass in the resulting client that was returned from the accept TCP client as an argument to t.start. And once again, this is called a parameterized thread start, okay, because we're sending in an object to the start method for the thread. Let's take a look at the client code, okay? So I'm going to move this out of the way, open up the client app and drag that right down. This will look a whole lot like the other example. In fact, it should be identical because there's really no change. Okay, quick review here. We got our echo client and we have one big main method. First thing we do is we'll create a TCP client object connecting to port 127.0.0.1. On port 8080, we create a stream reader and a stream writer. Yeah, note that this is all in a try-catch block because if there's no server listening on IP address 127.0.0.1 port 8080, that'll throw an exception. And most of this network code will throw some type of an exception if it can't get a stream, et cetera, et cetera. So most of the code that's going to give you a problem is right up here in the first 2 or 3 lines. And then we create an empty string. We have another while loop that repeats continuously until it gets the word exit. And then we send something to the server. We expect something to come back from the server and, write that to the local console. So this code is exactly the same. The difference is the server is multi-threaded, so we can crank up as many of these servers as we want, or clients, as we want, and connect to 2 or 3. For one person, it's 2 or 3 is doable, right? You can go between. Any more than that, it gets to be a little busy. But if you had a classroom of people and you had one server going, you can have as many people hitting that little server class because it's multi-threaded as there are students in the classroom, right? All they need to know is you'd have to rewrite the program to listen on a particular port or IP address besides 127.0.0.1, and you'd have to rewrite the client to go to the particular server. And that's a trivial change. So let's take a look and see how this runs. So I'm going to crank up, go back to the code here. And let me go to the server first. Open up my console, change directory. And I'm going to compile. Okay, so I've got me a server now, and I can just go ahead and start it. And let me pull that down here so we can see it. All right, so my server is waiting for an incoming client connection. Let me change to the client. And compile it. All right, and then I can go ahead and start. And it's, like I said, it's the same as the previous example, Echo Client. Let me pull that in so we can see it better. And we can minimize this console. Now we got our server in the upper left-hand corner, and we have our client down here. Let me expand this one more time And I'm going to go ahead and start another client. Losing my mind. All right, there we go. Now, let me bring that into play here. Okay, so we got two. Here's our server. So what we saw was each time I started a client, I started this one first. The server was waiting for an incoming client connection. It accepted the first one and then immediately went back to waiting for an incoming client. I started this one next, this client, and it accepted, and now it's waiting for another connection. So it'll keep doing this. Now, as soon as I'll go to this one, the first one I did, and I'll type a message. Hello from client 1. Okay, so I know it's coming from that one. I'll go up here and I'll type hello. Hello from client 2, and I'll hit return, and we'll see in the server it echoes that message and sends it back to that client. Okay, and that's pretty much your multi-threaded Echo client server app. To review, your server uses a threading namespace, and there's a class in there called thread. And it listens for incoming connections using the TCPListener class. And as soon as it detects one, it creates a new thread and passes that thread the name of the method that it's supposed to use to process the client connections. And then when we start that thread using t.start, our thread.start method, we pass in the client connection that's going to be used for that particular thread. And that's how each of these clients are talking to their own unique server-side TCP. You're pretty much only limited by memory. Okay, let's see what happens if I exit. EXIT. Okay, so it closed that client connection, and I still got this one. So let me test this one. Okay, so we still got a connection with client number 2. And if I exit this one, then what I didn't put was, a message that says, it's still listening for incoming connections. So I can go ahead and start another connection just to prove that. And there we go. Okay. I'd accepted the new connection, is waiting for an incoming client. So hello. One more time. So your imagination's the limit as far as what you can do. This just demonstrates an Echo, a multi-threaded Echo server. But the next section, we will talk about something a little bit more involved. Let's take a look here. We went through the code. Okay. We went through, that's the client. Okay, so I did make a couple changes here. Let me go through. So you see in the book, I've got some yellow text. That's because I added some diagnostic coding. Okay. So let's see here. Oh, multi-IP. So right now we're listening on, IP address 127.0.0.1. Okay. But we want to listen for any IP address. So I will address that in the next video. How do we make a multi-homed, okay? How do we make a multi-homed, multi-threaded client server? And that will be discussed in the next video. So thanks for watching this one. And if you have any questions, you know how to email me. All right. See you in the next lecture.